Welcome to the advanced level of the indices. We have these questions here to be tackled together. Olariwaju is my name. Teaching is my calling. Let's start with the first question. The cube root of 8a raised to power minus 6. Let's recall. If we have square root of x, similarly, we can say square root of x is still the same thing as x raised to power 1 all over 2. What do I mean by this? From the sixth law of indices, inasmuch the power, the numerator, will become the root of the base that we have here, then definitely x raised to the power of 1 all over 2 is still the same thing as square root of x. Once again, it's not out of place if we say cube root of x is the same thing as x raised to the power of 1 all over 3. Because naturally, if you are given this, it's going to end up making use of this sixth law of indices. The numerator here will be the root of the base, so which will result to cube root of x. These are just instructions that will enhance how we are going to solve the following questions. Now let's proceed with the question number 1. Cube root. So we can choose to say 8 raised to the power of 1 all over 3. Likewise, a raised to the power minus 6. Now let's see what we shall have. 8 raised to the power of 1 all over 3 multiplied by a, which is already raised to the power of minus 6. Minus 6 is already given as the power. Now, because of this cube root, so multiply by 1 all over 3. 8 raised to power 1 all over 3 is still the same thing as cube root of 8. And the cube root of 8 is going to be 2. Why? 2 multiplied by 2 multiplied by 2 will give us 8. So the cube root of 8 is perfect there. We have it as, I beg your pardon, the cube root of 8, we have it as 2 instead. Now we have our a raised to the power of minus 6 multiplied by 1 all over 3. 3 here, takwa. 3 here, takwa. We are left with what? Minus 2. By the time we cancel this, 3 goes here 1, 3 goes here 2. We are left with what? Minus 2. Don't forget that we are having 2 multiplied by a raised to power minus 2. So this raised to power minus 2 is only working for a. 2 is not involved. So we shall proceed by making use of the fourth law of indices, where this minus as the power will become 1 all over. So we are going to have, let's put this multiplication sign for clarity. It's still the same thing. So we are going to have 2 multiplied by, because of this raised to power minus, we shall have 1 all over. What do we have left? A raised to power 2. Now we have 2 multiplied by 1, we have 2. So this is going to result in 2 all over a raised to power 2. Easy. So the next question, question number 2. This is quite interesting because we start by making use of this fifth law of indices. We just need to make use of the fifth law of indices to start with. And how do we go with that? We have our square root already. 2 multiplied by minus 1 over 3. This will result to 125 raised to the power of 2 multiplied by minus 1. We have minus 2 over 3. That place is settled. Let's proceed. This is square root. And it's still the same thing as raised to the power of 1 all over 2, if you can still recall this. So we are having 125 raised to the power of minus 2 over 3. Now multiply by this square root, which is going to be 1 all over 2. Now we can cut 2 here, tapwa, 2 here, tapwa. We are left with what? 125. 2 has cancelled 2 here. You are left with 1 minus 1 all over 3. And because of this raised to power minus is an inverse sign, we are going to turn this one to become, because of this minus, it becomes 1 all over 125. Then what we have left? Everything raised to the power of 1 over 3. And raised to the power of 1 over 3 means cube root of what we have as base. So we have the cube root of 1 over 125. The cube root of 1 is definitely 1. 1 multiplied by 1 multiplied by 1 will give us 1. Fine. And the cube root of 125 is 5. That's our answer. Easy. So the third question. We have this as decimal. As the question presents itself as decimal, what we shall do here is to convert it to fraction. Let's quickly recall. Let's quickly do this for those that might have forgotten. If you are given 2.5 and you want it to be in fraction, all you just need to do is to move your decimal point to the right. So the amount of times you move is 10 times you are going to put at the base of this value. So if you are moving this point to this place, you are going to have 25 now because the point is no more there. So you have moved it how many times? Just once. That's going to be what? Over 10. So if you punch your calculator, 25 over 10 will give you 2.5. Furthermore, let's assume the question was 2.55. We are moving it how many times? 1, 2. So because we have moved the point twice, it's going to become 255. Everything all over, we have moved it twice. So that's going to be what? 10 multiplied by 10. So we are going to have 100. By the time you punch your calculator, you have the same value. Now let's go back to the question. We have to convert this one to fraction, our first one. So, by the time we move our points to the right, 1, 2, 3, we are going to have 27. Fine. 27 over how many times did we move? We moved it 3 times. That is 10 times 10 times 10. That will give us 1,000. Now raise to the power of everything, raise to the power of 2 over 3. Now we shall apply the 7th law of indices that we have over here. The base here of the fraction will become the root of what we have here. So that's going to be cube root of 27 over 1,000, everything raised to the power of 2. Now, the cube root of 27. The cube root of 27 is going to be 3. Because 3 multiplied by 3 multiplied by 3 will give us 27. So the cube root of 27 is going to be 3 all over. The cube root of 1,000 is going to be 10. 10 multiplied by 10 multiplied by 10 will give us 1,000. So everything raised to the power of 2 because we've only done this cube root. Now everything raised to the power of 2. Now 3 raised to power 2 will give us 9. 3 times 3, 9. And 10 raised to the power of 2 will give us 100. Easy. Fourth example. Here we have 2x in brackets to experience the power of 1 all over 2, which we shall multiply by 2x, which is already raised to the power of 3. That the 2 we experience the power of 3 all over 2. So we proceed by using the power of 1 all over 2 for this 2. Likewise, the x here raised to the power of 1 all over 2. Then we have the multiplication sign. 2 raised to the power of 3 all over 2. Three multiplied by 3 all over 2. Let's continue with the same value here. Now, as for this x, 3 multiplied by 3, we have 9 all over 2. Let's still write it all over again. 2 raised to the power of 1 all over 2. We also have another 2 here, raised to the power of 3 all over 2. So considering the first law of indices, we have the same base here, which is 2 and 2. So we group them together. We now have 2 raised to the power of 1 all over 2. The multiplication sign here, we turn to addition. We have plus, then 3 all over 2. Also, we have x and x here, which are the same. So we apply the first law of indices on them. So we have multiplied by x raised to the power of 1 all over 2. This multiplication sign will turn to addition. Then we have 9 all over 2. So we do fractional addition here, which will result to 2. The base is already as 2. The LCM is 2. So we just add the 2 numerators together. So 1 and 3 will result to 4. Multiply. So for the second part here, we have our x. So the base of the fraction, the denominator of the fraction, they are the same. So we have our 2. So for the numerator, we add them together. So we have 1 plus 9 to give us 10. So 4 over 2 will give us 2. We have 2 raised to the power of 2. Then x, which is raised to the power of 5. Courtesy of n divided by 2, which will give us 5. We have our 5 here. So 2 raised to power 2 will result to 4. Then we have x raised to the power of 5. Lo and behold, that's the final answer here. Easy. Forward with further examples under advanced level of indices. We have this as questions from indicial equation. They became indicial equation because of the presence of the equal to sign. Now, we have the first question here, which is y raised to power 1 all over 2 equals to 3. So technically, we are going to find the value of y. So we can solve it in two ways. The conventional way, or making use of indices or indicial technique. So let's proceed. In order to eliminate the power as 1 all over 2, we just simply need to multiply the power by the inverse of the power. So the inverse of this power is going to be 2. Or we can assume to say, okay, 2 all over 1, of which 2 over 1 is still the same thing as 2. So the inverse of this is 2. and we shall use it to multiply the left side of the question along with the right side of the question. So we shall have y already raised to the power of 1 over 2 multiplied by 2 over 1, as some might have it, to give us 3 raised to the power of 2 over 1. And 2 over 1 is still the same thing as 2. But for the benefit of that, let me deliberately write 2 over 1 here. So 2 will cancel 2, 1 will cancel 1. So you have only y. 2 tapwa 2, 1 tapwa 1. We have just y. To give us 3 raised to the power of 2. So we shall have y to give us 3 raised to the power 2 will become 9. But solving it conventionally could also be, this is going to be square root of y. The square root of y to give us 3. And in order to eliminate the square root, we need to do what? Square both sides. So by the time you square both sides, the square will tap the square root. So you now have y to give us 3 raised to the power 2 will give us 9. Easy. Now to the second question. N raised to the power of minus 2 over 3. As said earlier, once it is raised to the power of minus, so far the number is not fraction, it's going to become 1 all over. So we have 1 all over n, then everything raised to the power of 2 over 3. We are no more placing the minus. It has already done its task by placing 1 all over n to give us 9. So in order to eliminate this power, we multiply by the inverse of the power. So the inverse of 2 over 3 will become 3 over 2. Multiply by 3 over 2 to give us 9 raised to the power of 3 over 2. Now 3 tapwa 3, 2 tapwa 2. Everything clear. We have 1 over n, all to give us 9 raised to the power of 3 over 2. So making use of the law of indices as the seventh one states, we have the square root of 9 raised to the power of 3. Square root of 9 then raised to the power of 3. So moving on, 1 all over n will give us the square root of 9 is definitely 3, then raised to the power of 3. So we have 1 all over n to give us 3 raised to the power 3 is 27 equals to 27. Let's assume it is 27 over 1. So by the time we cross multiply, n multiplied by 27, this will give us 27n. Then 1 multiplied by 1 will give us 1. So making n subject of the formula, your n is going to result to be 1 all over 27. Easy. Now to the next one, question number 3. 2r raised to the power of 3 over 2 to give us 54. First thing we shall do here is to make r subject of the formula. So we divide both sides by 2. We now have our r raised to the power of 3 all over 2 to give us 54 divided by 2. So 54 divided by 2 will give us 27. On getting 27, we need to eliminate this power. So we multiply the two values, the two figures from the left and the right side by the inverse of the power here. So this will result to r raised to power 3 all over 2 multiplied by 2 all over 3. 27 raised to the power of 2 all over 3. They cancel each other. We now have r equal to the cube root of 27 raised to the power of 2. R will give us the cube root of 27 is going to be 3. We have 3. Now raised to the power of 2. So R will give us 9. We have a very beautiful one there. Question number 4. We have 3 and we have 81. There is something called indexing when you are tackling questions from initial equation. So far we have 3 here. This 81, we can index it to give us, so that we have 3 as the base. Then we eventually power it with a suitable figure. So when you think it now, 3 raised to power 2 will give us 9. 3 raised to power 3 will give us 27. What about 3 raised to power 4? By the time you multiply 27 by another 3, will definitely give us 81. For question number 4, we already have our 3 raised to power c minus 1. So we want to index the 81. So this will give us 3 raised to the power of 4. Because by the time you multiply 27 by 3, we are going to have 81. So 3 raised to power 4 is still the same thing as 81. And when your equation is solved to this level, the base will cancel each other. We are now going to be left with c minus 1 to give us 4. Our intention is to make c subject of the formula, so we have c equal to 4, which is already here. By the time minus 1 comes here, it becomes plus 1. So our c will end up with the 5. Easy. Number 5. We state 5 raised to the power of x plus 3 all over 25 raised to the power of 2x minus 3. Everything to be equal to 1. It is equally correct to assume that this 25 is still 5 raised to power 2, because 5 raised to power 2 is still 25. So let's see what we have from the process we shall embark upon here. This division sign, I would prefer to spread it for clarity. Now we have 5 raised to the power of x plus 3. We have a division sign here, which I choose to spread out like this. Now instead of writing 25, I'll write 5 raised to the power of 2. The purpose of this is to have similar base for us to be able to process it even further. So we have 5 raised to power 2 now. But already stated here, we have 2x minus 3. So I'm going to write that by multiplying it with the power, which is 2x minus 3, all to give us 1. Fair enough. But at the same time, as given at the third law of indices, x raised to power 0 is 1. And I said earlier that anything raised to power 0 ends up to be 1. 50 raised to power 0, 1. 1 million raised to power 0, 1. Even myself raised to power 0, 1. You watching this video raised to power 0 is 1. So anything raised to power 0 is 1, apart from 0 itself, which will be discussed in subsequent videos. Now we have 1 here. In order to have all the bases to be the same, we now assume to write it as 5 raised to power 0 because eventually 5 raised to power 0 is still 1. Now it's getting clearer. Now we proceed by saying 5 raised to power x plus 3 divided by 5. We open the bracket here. 2 multiplied by 2 we have 4x, and 2 multiplied by minus 3 we have minus 6 to give us 5 raised to the power of 0. This division sign will become minus by the time we apply the second law of indices. So we have 5 and 5 here. So the powers will be put together, considering that this division sign will become minus. So we have x plus 3. Division sign will become minus. But the minus is meant for everything here. So we have it in brackets. 4x minus 6, close the bracket, to give us 5 raised to the power of 0. Here, we need to be very careful. A lot of students make mistake here. They will just apply the minus for the 4x, leaving minus 6 alone, or failing to apply the minus for the minus 6. The minus is meant for all the powers over there. So we shall have minus 4x. The minus times minus will become plus. We have plus 6 to give us 5 raised to the power of 0. Now, let's equate what we have here by connecting the like terms. We have an x, and I am owing 4 x's. So by the time I pay 1 that I have, so I'll be left with deficit of minus 3x. So we have 5 raised to the power of minus 3x. Then 3 plus 6 will become 9. This will be equal to 5 raised to the power 0. Now the base will cancel each other. Then we have minus 3x plus 9 to give us 0. We are looking for x. So we are going to make x subject of the formula. So we work it further by saying minus 3x equal to this 9 crosses to the other side. It becomes minus 9. So we divide both sides by the coefficient of x, which is the minus 3. The figure that holds the value of the x, which is minus 3. We have x to be equal to minus 9 all over minus 3. Then we have our x to be equal to minus cancels minus 3 here 1, 3 here 3. Your x ends up to be 3. Easy. Let's proceed to the 6th question. 5 raised to the power 2 open bracket x minus 1 close bracket multiplied by x. 5 multiplied by 5 raised to the power of x plus 1 to give us 0.04. Let's move. The 6th question. 5. We open this bracket. 2 multiplied by x. We have 2x. And 2 multiplied by minus 1. We have minus 2. This is the multiplication sign. I'm rewriting that. Multiplied by 5 raised to the power of x plus 1. As it is, I write. Now, equal to 0.04. Considering changing decimals to fraction, as done in the earlier video, we shall move the points to the right side, and we shall count how many times? 1 and 2. So we have 4 all over 100. We move this and this. We pick our 5 as the similar base. We now have 5 equal to 2x minus 2. The multiplication sign becomes addition to give us x plus 1 equal to 4 over 100. We think it logically. There is no way we can index this to give us 5. But rather, we can say 4 goes here, 1, 4 goes in 100, 25. Now, 1 all over 25. Let's collect the like terms for this. 5, 2x, and another x. We have 3 of those x. 3x minus 2, then plus 1. I'm owing 2, I now have 1. I've reduced it to minus 1. We have minus 1 to give us 1 all over 25. Let me take you back to this law of indices. 1 all over 25. As it is 1 all over 25, it's still the same thing as 25 raised to power minus 1. Because once it is raised to power minus, it becomes 1 all over. So it's not out of place to say 25 raised to power minus 1. Because by solving this one, we can say raised to power minus will become 1 all over, and we will left with 25 raised to power 1, which is still the same thing as 25. It's getting clearer now. We can now index this 25 to give us 5 raised to power 2. 5 raised to power 3x minus 1 to give us 5 raised to power 2 multiplied by initial value of minus 1, which is already placed at the power point. We now have 5 raised to power 3x minus 1 equal to 5, 2 multiplied by minus 1, it becomes minus 2. Now, 5 can equal 5. So, we have 3x minus 1 equal to minus 2. Minus 1 comes here. We have 3x here already equal to minus 1 coming down there will become positive 1. Then we have what? Minus 2. 3x equal to 1 minus 2. I have 1 and I am owing 2. I pay the 1, then I'm left with minus 1. Minus 1. Then x is going to be, the coefficient of x here is 3, so it's going down here. Minus 1 all over 3. Easy. Thank you so much for your time. I'm leaving you with this 4 tasks to answer and practice from your various homes. And please do me the honor by dropping your responses for these questions at the comment section. And please subscribe to this channel, share with your loved ones, and remember to always like this video. I can't wait to see you in the next class. Until then, have a wonderful day.